Okay, so I realized I just did this entire problem without doing the audio, so I'm just going to run over what I did on the screen. So I started up here with the two equations that we just ended with. This particular equation was gotten because we knew the x, how far it was going to go, and we had found that this is how fast it's going to be going in the x, the combination of these two. The total answer of speed times the cosine of 15 times time, and we didn't know these two values, and that's why we chose this equation right over here, because we knew the y, we knew the acceleration, and so in order to get these two variables into our second equation, we chose velocity initial in the y, and we chose time. And that's what gave us this equation. And now we're at two unknowns in two different equations. So to start off, what I usually look at is the more complex of the two equations. I see that I've got one vt here, I've got a delta t, and I've got a second delta t that is squared. Due to the having two of those to plug in, I'm going to think that it's going to be easiest to solve for vt, so that's what we do first. So we come over here, and remember that cosine of 15 is essentially just a placeholder for a different number. So I can treat it just like a standard constant. So I divide cosine of 15 and delta t on the other side, which gives us this right here. Then, upon solving for this, I see that I just need to substitute in here. So I'm going to rewrite this entire equation, but instead of writing vt, I'm simply going to have this mess here, right here. Now, after having it plugged in, got the exact same equation as before. Apologies once again for the handwriting on this. I hope I get a little bit better at it. I see some things are nice that simplify. The time that was up here is going to cancel with the time that came out of this equation over here. So now, actually, everything that's left over is just a constant. Now, if you remember, you actually can take sine, divide by cosine, and make tangent. But if you don't remember this, it's not good to necessarily just throw it into the problem unless you're used to it, because this is kind of a complex problem. Now all we actually have to do is not too bad. We just have to subtract this to get it to the other side, which gave us, and it's kind of hard to see on the screen now, this used to be negative 52.1 times sine over cosine, and this used to be negative g over 2 times delta t squared. And then it's just basic algebra. I have g over 2 over here. I'm sorry, I have two negatives first. So the negatives canceled. That's why they're pluses now. And then to get g over 2 to the other side, I multiply by 2 over g, which is why this whole mess cancels here. And then it's 2 over g. And the only thing left was t squared, so I square rooted the whole thing. And then I just plugged everything here into the calculator. And the calculator spits out 1.68 seconds. That tells us the total amount of time that the object is in the air. After finding that, though, remember that that's not what it asked for. It asked for how fast, which is ultimately this vt right here. So all I got to do is take this equation again and plug time in here. Technically, you could also do that over here in this equation, but as you can see, due to the complexity, that kind of makes it a little bit trickier. So let's just use this one. So we come down here and take 52.1 meters, 2 meters, times cosine of, divided by cosine of 15 times 1.68, which is what we just got right there. And that gets you 32.1 meters per second. And if you're curious, that's also 72.2 miles per hour. And that's how you do that problem.